Okay, welcome to the second part of the refresher lecture. And in this part, we're going to discuss validity. In the previous video, we discussed reliability. And then we discussed that reliability is the degree to which a measurement or which a measure measures the same thing over and over and over and over again. So to what degree, if you have, for example, a mathematics test, if you give the mathematics test to the same student 10 times, then to what degree does that student have the same observed test score each time he or she takes the test? So reliability asks the question, is this measure measuring the same thing over and over and over and over again? Now, what we saw in classical test theory, since the classical test theory assumes that the observed score is part true score, part error score, and assumes that the true score stays the same, while the error score changes from measurement occasion to measurement occasion. Reliability in classical test theory is that part of the total variance that could be assigned to true score variance, so to the variance in that part of the observed score that you're actually after, the true score. But we also mentioned that even though classical test theory divides an observed score into a true part and an error part, the only thing we can do in practice is divide variance into systematic variance and non-systematic variance. And the systematic variance and non-systematic variance are not the same as true score variance and error variance. We often pretend that they are, but there are other systematic sources of variance that have nothing to do with the true score that we're after. Alright, so as I said, reliability. Are we measuring the same thing over and over and over again? Now, even if a test is really reliable, so even if the test measures the exact same thing over and over and over, there's still no guarantee that that thing that we're measuring all the time is actually the thing that we're after. To give an example, think about a scale, and let's say that the scale isn't calibrated properly. So if nobody is standing on the scale, instead of reading 0 kilograms, it's actually reading 5 kilograms. So it's not calibrated properly. Now, let's say that apart from that, the scale is incredible. So every time I step on the scale, I get the same reading. So it's really reliable. I get the same kilogram reading every time I stand on the scale. However, that reading is not my actual weight. It's my weight plus 5 kilograms. So even though the scale is really reliable, it's not valid. And since we're using measures to actually measure something that we're interested in, we want to make sure that what we're measuring actually is that thing what we want. So measuring the same thing over and over is not enough. We want to make sure that the thing also is the thing that we hope we are measuring, that we want to measure. Okay, now up until this point, I've basically been talking about validity like it's some kind of black and white matter. So a test is either valid or it isn't. Thing is, it's not as easy, unfortunately. There's degrees of validity, so a test can be more valid or less valid. Same basically applies to reliability. A test can be more reliable or less reliable. The readings can be more consistent or less consistent. But at least with reliability, we had only one concept. Right? The concept of reliability, are we measuring the same thing over and over and over? Validity is slightly more difficult because there isn't one general validity construct. There are actually subtypes, and validity is made out of different components and different things about the measure that we need to check. So it's slightly more complicated and slightly more diverse than reliability. What we can say about validity though, even though there's multiple components, it is all about, are we actually measuring what we want to measure? And because of that, there's one thing we can be absolutely sure of. If a test is not reliable, it's also not valid. If it's not measuring the same thing each time you use the test, then it's definitely not measuring the thing that we want every time. So if it's not reliable, it's not valid. The opposite doesn't hold. So it could be, like with my scale example, that the measure is really, really reliable, but that it's measuring the same thing is no guarantee that that thing is actually what we wanted to measure. All right. Now, as I already mentioned, validity has multiple, let's call them subcomponents. And the overarching term, the overarching construct that we're looking at is construct validity. Construct validity is basically looking at a measurement instrument from multiple angles and checking whether every angle is covered, more or less. Now, construct validity has, I'm going to throw them all in, 5 components. First component of construct validity at the bottom is test content. We want to make sure that a measurement instrument measures or asks about all relevant topics related to a certain construct. Now, this sounds really vague. Let's take a depression questionnaire as an example. If we want our depression questionnaire to be a valid measure of depression, we need to ask about all the symptoms that are related with depression. We can't only ask whether people feel sad or not. We need to ask about whether people feel sad, whether they have problems sleeping, whether their appetite changed recently, whether they have suicidal thoughts or not. We need to add all those different components, all those different symptoms to the measurement instrument. If it doesn't cover all key symptoms or key components related to the construct that we want to measure, test content is not okay, it's not covering the entire construct, and that means that that has a negative influence on construct validity. The second component of construct validity that we need to look at are the response processes. Now, the response processes are not necessarily a characteristic of the test. It has to do with the individuals taking the test, but remember, one of the difficulties with measuring in social sciences is that our participants are units of interest, to say it in a really abstract clinical way. The problem with them is that they react to the fact that they're being measured. That's what makes measurement in social sciences so difficult. If you're in physics, you can just measure an atom, and the atom doesn't care that it's being measured, it doesn't change its behavior or anything. People do. So people interact with the measurement instrument, and that's why this more people-oriented component, response process, are also part or also related to the construct validity of a certain measure. Now, as an example of why response processes are important, let's think back to kindergarten, or well, maybe not kindergarten, but at least when we were young, and we had to learn these count tables, right? So 1 times 1 is 1, 2 times 1 is 2, 3 times 1 is 3, etc., etc. The goal of those tests were for us to memorize them. So we needed to know by heart that 4 times 5 is 20, for example, and that 6 times 6 is 36. We need to know that by heart. So the response process that we're after with those count tables is digging up information from memory. However, especially for the easier count tables, there's no guarantee that the child isn't just multiplying really quickly in his or her head. So maybe he doesn't know by heart that 4 times 1 is 4. Maybe he or she can just calculate that really, really quickly. And then the response process does not match the process that we're after. And then we're not measuring knowledge, certain basic knowledge about math anymore. We're actually measuring the ability to multiply really quickly. And if multiplying really quickly is not the concept that we're after, that different response process has a negative influence on the construct validity of the test that we use. Third component is internal structure. Internal structure is basically what we're measuring when we're doing factor analysis, which is the topic of one of the future videos. And internal structure basically says if our measurement instrument is supposed to measure a certain number of constructs, then there should also be a certain number of underlying factors in our measurement instrument. Easiest example is probably the Big 5 personality questionnaire. As the name already suggests, we're assuming that personality has 5 distinct subfactors, the Big 5. So if we run a factor analysis on that Big 5 personality questionnaire, we need to find 5 factors. If we don't find 5 factors, the internal structure does not match the concept that the Big 5 personality questionnaire is supposed to be measuring. So the internal structure needs to measure the hypothesized theoretical internal structure, the construct that we're after. Fourth one is the association with other variables. That's what we see most often as a check for validity. We know based on theory that constructs in social sciences are related in certain ways to others, and we want to make sure that our measure of a certain construct shows the hypothesized relationship to the measure of another construct. So for example, we know that depression and anxiety are positively correlated. The more depressed you are, the more likely you are to be anxious. So if we have a new depression questionnaire, we want the scores on that depression questionnaire to be positively correlated with those of an anxiety questionnaire. If our depression questionnaire is negatively correlated with an anxiety questionnaire, then that's weird. Then what our measure is measuring doesn't seem to match with the construct that we want it to measure. If it's really measuring depression, it should be positively correlated with this anxiety questionnaire, and it isn't. So that could be an indication of a problem. So another part of construct validity, the test measures need to show the expected association with other variables. And I gave an example of a positive correlation because things are supposed to be associated with each other. This also includes cases where we know that something should not be related to something else, and then our questionnaire should not be related to another questionnaire for that second measure. So if it's not supposed to be related, then it shouldn't be related. So for example, IQ has nothing to do with gender, so we don't want our IQ questionnaire to be different, significantly different between boys and girls. If that's the case, something is up with our questionnaire that we need to look into. Finally, consequences of use. This aspect basically states that the consequences of our measurement instrument should be the same for all groups. There aren't allowed to be any differences. Again, this is maybe more people focused than actually questionnaire focused, but it is an important part of construct validity. An example where we see that goes our way is when we're looking at university admissions. Unfortunately, it's the case that students from an ethnic minority background, if they have a really high SAT score, then that SAT score is taken less seriously, is weighted less in the decision to admit him or her relative to the ethnic majority groups. So for example, if you're in America, you have a certain SAT score. If you're an American and you have a certain SAT score, your chances of being admitted to the university are higher than those of an ethnic minority with the exact same SAT score. So that's something that we obviously don't want, and that's one of those consequences of use. There should be no difference between the meaning and between the consequences of a certain score between different individuals. Alright, now I also included some examples here. So for the test content, like I already said, we need to make sure that all important information is there. So for the depression questionnaire, don't just ask about being sad. For the internal structure, this is basically factor analysis. So if you're using a Big 5 questionnaire, you should find 5 underlying factors. If you have a mathematics test that should be measuring addition and subtraction, there should be 2 factors, not 3, not 1, there should be 2. The response processes, you should be sure that you're really measuring what you're supposed to be measuring, and it also means that your participants should be doing what they are supposed to be doing. This is a really tricky part, but it is an important part of construct validity. The association I already mentioned, so depression and anxiety should be related, so your measure of depression should also be related to a measure of anxiety. And here is what I mentioned before. So my example was more or less limited to showing that there's an association between two measures for which the constructs that they're supposed to be measuring are also related to each other. So that was this convergent validity. This discriminant validity is what I also mentioned. So if things are not supposed to be related to each other, the measures also shouldn't be related. So if IQ is not supposed to be related to gender, then there should be no correlation between gender and your IQ measure. Now, this discriminant, but mostly this convergent validity, can be further subdivided into specific types of convergence validity. I'm just going to mention them to be complete, but just remember association with other variables. We're looking at relationships. Things are either related and they should be convergent, or things are not related and they shouldn't be discriminant. Now in this convergence validity, the measures that we're trying to correlate with each other, they could be different types of measures. They could either be measures that we administered at the same time. So if I'm sticking with my depression and anxiety example, I give you an anxiety questionnaire and a depression questionnaire, the same testing session. Then if I check the correlation between those two questionnaires, what I'm doing is concurrent validity. I'm checking correlation between test scores measured at the same time. If I'm giving you a depression questionnaire now, and I give you an anxiety questionnaire next year, then if I check the correlation between those two questionnaires, what I'm doing is I'm checking predictive validity. I'm checking the correlation between two measures that are apart in time. Now doing that with depression and anxiety is a little bit weird, but mostly you can think about tests that are supposed to inform us about whether people will be successful in the workplace, whether they will be successful at university, stuff like that. So does our test predict who will be successful a couple of years from now, either in university or in a certain job? Then we're looking at predictive validity. And finally, one that you don't see so often, incremental validity. This just states, okay, if we look at the relationship between our test and another measure, does it give us anything, does it predict anything above and beyond what other predictors were already telling us? We don't see this one so often. Alright, already gave an example of that. There is one more validity I want to mention, because we're gonna get back to that later on when we're looking at real life decision making. Construct validity, that's the one, like I said, the most overarching, the most general form of validity with the 5 subcomponents. But you also see a whole bunch of other validities mentioned in the literature quite often. For example, you see face validity, which is basically just a check for the content part of construct validity, but it's really low level. It's basically just giving a person a questionnaire and saying, okay, have a look. Do you think this measure is measuring what we think it is measuring? If the person then goes, yeah, I think so, face validity is okay. If the person goes, no, I don't think so, then face validity wouldn't be okay. So face validity is one of the things that you see, but it's also the weakest form of validity that you can find. But the point is, you see different types of validity mentioned next to that construct validity. One of those other types that you see often, and one that's actually quite useful, and which is therefore also one I want to measure, is called criterion validity. And this criterion validity is closely related to this predictive validity that we saw earlier. So when we're looking at convergent validity, is something related to something else. And if that something else is in the future, we would call that predictive validity. Criterion validity is really closely related to that. Criterion validity basically says we have a criterion, we have a gold standard somewhere in the future, and we want to make sure that our test can predict how a person is going to perform on that gold standard. So think, for example, at the end of your high school days, you're going to take the SAT. So you could say that the SAT is like a gold standard. The SAT is like the gold standard for checking how much a child learned during his high school years, right? Okay, then criterion validity would check to what degree our measure can predict a child's SAT scores, let's say 4 or 5 years from now. Another example of criterion validity is when we're thinking, well, let's use the COVID-19 crisis as an example. Can we predict whether somebody has COVID-19, yes or no? So we have these biological tests, so we can check your blood and we can check different information. We can check how your lungs are doing. We can take an X-ray picture of your lungs, and all that information will give us eventually accurate information about whether you contracted COVID-19, yes or no. And let's say we came up with a really quick test, that asks a person 5 or 6 questions, and based on the test we want to determine whether somebody likely has COVID-19, yes or no. Then criterion validity basically checks whether our shortened quick test can accurately predict whether a person will have COVID-19 according to the foolproof measures of like X-ray picture of the lungs and blood typing, etc., etc. All right. Now, I'm going to mention this one more time because it really is important, the difference between reliability and validity, especially since reliability is something that you see mentioned in articles a lot, while validity isn't mentioned that often, although I think it should be. Reliability is important, but reliability really is just checking whether your test is measuring the same thing over and over and over again. Now, we like to pretend that if our test is measuring the same thing over and over and over again, that means that our observed score is really close to our true score. But as I mentioned before, that's not necessarily the case. We can never distinguish between true score and error score. We can only distinguish between systematic variance and error variance. So reliability is important. Is it measuring the same thing over and over and over again? But even if that's taken care of, even if we know that the test is reliable, yes, it is indeed measuring more or less the same thing over and over and over again, we need to make sure that the thing that is being measured over and over and over again is the thing that we're interested in. And that second step, making sure that we're actually measuring what we want to measure, that's validity. And like I said before, reliability is important, because if reliability isn't okay, validity definitely isn't okay. But reliability alone isn't enough. We really need to check validity, we need to check construct validity and its 5 components. We need to check the content, we need to check the response process, we need to check the internal structure, we need to check the relationship to other variables, so discriminant and convergence validity, and we need to check the consequences of a test for different groups. Alright, that's it for this second part of the refresher lecture. In the next video we're going to continue with dimensionality, which, let's be honest, is basically a fancy way of saying we're going to look at factor analysis.